Actually, one of the applications of our collaboration in sports neuroscience had to do with testing. I want you to explain what term the Warrior-Worrier gene. And we tested fighters, we tested athletic controls, and then we just had, I think, sedentary people. First, explain the genetics of the warrior versus worrier gene and why people in high-risk sports, be it fighting, it could be big wave surfing, it could be rock climbing. What is different about their behavior versus someone who would be more in the worrier class of the genotype?
Yeah, and again, why people should talk to each other across different fields. So this is I don't know if you know that, sorry, Tony. So basically, it's like I was studying a gene in my lab, and as you would call them, sedentary people, and I would just call them research participants. And it's a gene called the Warrior/Worrier gene, and I was talking to Corey about it, and he's like, he got really confused because he was like, okay, so you tested this on warriors. I'm like, no, just regular people. He's like, then how do you call it the warrior gene? I'm like, oh. So we did, like, we tested it, and it was, I think, the first time that gene has been tested in like MMA fighters. But it's a really interesting gene polymorphism because it's COMT gene, right, produces an enzyme, right? So enzyme, breaks down different molecules. So this particular enzyme breaks down dopamine. So in other areas of your brain, you have a different mechanism to get rid of dopamine, right? A dopamine transporter. In your frontal lobe, you mostly rely on this enzyme to break down dopamine. So if you have one version of it, the enzyme doesn't work very well. You're not breaking down dopamine as efficiently. And if you have the other version, right, you carry the other allele, you are breaking down a lot of dopamine, right? So we have one set of people that have ostensibly, right, lots of dopamine at rest, and another set of people that have less in their prefrontal cortex. So what we and other people find is that at rest, it's great. You want to have more dopamine, and we've shown this in other studies with women. They're less stressed, right? They feel better. They're like, cool, everything's awesome. Except when you get stressed, right? When you add stress to the mix, that's also going to flood more dopamine into the prefrontal lobe. And it turns out that that's not good because a lot of biology kind of works on an inverted U. So you want to be in that kind of Goldilocks zone of dopamine. So those people that were doing great in the Goldilocks zone at rest, now we push them over and they can't really function well under like high stress environment. They're not able to do those things we need our frontal lobe to, like attention and thinking and processing. But then the other group, where they were kind of on the other end of that inverted U, they had low dopamine at rest. But now we give them stress and they're in the Goldilocks zone. So they almost are in this situation where under stress, they get kind of optimal dopamine levels and they're performing amazingly, right? So they're able to think better, right? Their processing is better, their attention is better. And so these are the warriors, right? They perform much better under stress.
Now, is there a sex difference regarding this? And I only ask that because it's almost always guys that do some of these crazy physical feats. I mean, if you look at big wave surfing, it's all guys. If you look at rock climbing, free solo climbing, it's pretty much mostly guys. And the fight sport, obviously women are coming into the fight sport, but it's still mostly guys who say, I want to fight. So is there some sexual dimorphism there?
Yeah, men. Well, we could talk about men for days.
We need to get Val in that conversation.
There is a sex difference in the sense that women have more dopaminergic projections going into their frontal lobes, about 30% more relative to men. So it could be, but with men, with that risk-taking behavior, we tend to look more at testosterone, especially in young people, because there is kind of a really close correlation between traumatic brain injury and when men have peak testosterone levels.
Interesting.
There's a reason I pay $800 a month for my son's car insurance.
I believe
company, they know statistics.
Whoa, 800, that's a lot. Holy crap.
I know, I need to talk to you. I don't know what I'm doing wrong.
Oh my.
I'm probably going to keep
one thing in defense of women and risk taking, doing like 3 aerials in midair and landing on a 4-inch balance beam to me is kind of risk taking. So kudos to the ladies in gymnastics out there. Yeah. That's pretty high risk in my view.
Yeah, I mean, at the same time, you want to have fear, right? Because one of these people who does these free solo climbs, we put him in an MRI machine, his amygdala isn't lighting up. So fear is it keeps us alive.
Right,
Some of these people, their fear responses aren't healthy either. You want to have a sort of right level that, and with the people with anxiety, it's sort of fear run amok. But the other end,
the muted amygdala is not all that good either.
That's when you get head injuries. So I think there's a host of things, like just individual differences, amygdala responsivity, testosterone levels, testosterone with cortisol, potentially that, COMT factor.
Interesting. So with the amygdala response, I assume there are people on the other side of that where they're in constant fear, like everything scares the crap
I mean,
out
that's
of them.
anxiety. That's generalized anxiety. That's really what it is. It's fear kind of gone haywire.
Boy, what a crappy way to live.